want you to know that's recording. Okay, so we're going to do statistics. I'm going to go through different the main topics. These are stuff that you could easily find in your definitions. So you're free to look back or whatever, but I need to make sure you understand the concepts. Just let me know if there's something you don't understand or you really need me to go over. Statistics is probably our easiest area, but they ask like 5 questions on the test usually for it. So, you know, I like to make sure you understand. Okay, so the first thing we're going to talk about is like the different sampling methods. This is where we kind of did that poster thing. Do you remember us doing that at the beginning? A long time ago? Yeah, it seems like.
Remember did like the height and everything?
Yeah, that's kind of the area that we're headed towards that. I don't know where my little list of vocab was to keep me on track. But that's a shocker. Okay, so we have sampling methods first. Okay, and that is an S. So we have a couple different sampling methods. The first that you know most without even thinking the word of it would be random sampling. That's literally what it sounds like. It's random. Everybody has a chance to be picked. Okay. And I probably won't write out all these definitions just for time's sake. You can either kind of put whatever you need for it or something like that. The next is simple random. That's when everyone has the same chance. Okay, so the only difference between random and simple random is that simple random says everyone has to have the same exact chance as being picked as everybody else. But random, it doesn't really care about their odds as long as everybody's being picked. Okay? If I go too fast, just gotta let me know. I'm not used to having 2 people freaking me out. Nice. Convenience is next. It is exactly what it sounds like. It is convenient. It is the easy way to do it. So like if I wanted to do a survey on how students felt about lunch, asking my classes would be the easiest thing for me to do because I'm a teacher and you're right there. If somebody wanted to know about sports, the easiest thing that's probably going to do is just go to a football field, right? It is what's simple. It creates a lot of bias because of that. Does that kind of ring bells of what we talked about before? Okay. So random, simple random, convenient. Voluntary is when you do it all the time. It's you actually volunteer for it. It's also called self-selected, and I cannot remember which one they like to use. I have to look back at it. I'll tell you this week sometime. So that's going to Hardee's and filling out that survey. That's getting a phone call and choosing whether you answer or not. It's those surveys at the bottom of the receipt that say call and have a chance to win $500. If it's volunteering in any way, it's volunteering. Even if in the classroom, if I say,
Brandon Burleson, if you're in the building, please come to the office. Your ride is waiting for you, Brandon Burleson.
Even if I had said, okay, well, who wants to tell me what they think about the school lunches? Though that was convenient for me to ask, it's also voluntary because then we combine the situation. You will notice, and I've noticed also on which release it was a couple of years ago, that they combined 2 of the things. They combined simple random, and I think they combined convenience. So be prepared to see that. Or no, it was systematic that they combined. So the next one is systematic. Systematic, there has to be some kind of system So something like every fourth person, something like that. Okay, so if I was doing a simple random systematic, if I picked every fifth person that came into the lunchroom to ask them how they felt, it is simple random. Every person has the same amount of chance of being picked, but that's how I started it. I just picked one person. After that, I just picked every fourth person. Did I dictate who the fourth person was in any way? Well, no, I didn't. Now if I said I was only gonna pick every fourth person with blue hair, I hope I didn't find that many, but brown hair, then that would take it just into systematic and out of the simple random, because everybody doesn't have the same chance. There's another one in there. What is it? This is why you keep your list.
Stratified?
Yeah, stratified is kind of grouping it into clusters. So stratified, if I put in, our room is stratified already. If I come around and ask, what did y'all get? It's asking the specific group. So it's already kind of grouped in one way. Usually stratified is grouped by either culturally or by gender. That's another one. By intellectual level in some way. Many different ways we separate people, even with denominations, things like that. So. I think that's all of them. And y'all okay with all those? Okay. Each of them have their own kind of bias. Each of them have their issues. Each of them are good in some ways. It depends on what you're aiming for, what you want to use. Now, this is mainly sampling methods of how to just run a survey. You could apply it to the same concept of like how to do an experiment or something, like picking people for experiments. But those are usually a little bit more involved. So normally we just say that this is simply methods for surveys. Which leads us into the next thing when you talk about the different types of studies you can do. Surveys is the first one. So you have study types. And you have surveys. You have experimental. Okay, please don't forget that experimental, the most common experimental group that you're going to have is a control group and then an actual experimental group, okay? So you would split it into a control group and an experimental group. This is not always the case, but it's a better experiment if you do. So if I'm trying to test whether a plant food works really well, I need to know what it was originally, because there may be other factors like the climate that season, where I can't compare it to what happened last year, or, just as simple as, did I go out there, people say that talking to plants help them grow, did I go out there and talk to them as much as I did last season? I have to kind of watch those factors, keep them even in the control group and the experimental. The only thing I can change is that one little thing, that plant food part. And if I change that one thing, what did it do? By having a control group, I take out that what ifs, it was caused by something else. So when you're talking about medicine, which usually experimental is, they have to have that control group say, okay, well, that takes care of this, these people that had this same issue. Well, they also had diabetes. Did that affect it? But if I have that control group, if I have people with diabetes, they also in that control group, and I can compare it likewise. Okay? Then you have observational. I know you know what observational means. It means you literally look, you don't touch, you do not affect it in any way. If you do change any outcome in it, then it is no longer observational, it becomes experimental. So if the principal walked in here and started showing you how to do something in math, that is no longer an observation and is now an experiment because you're adding 2 teachers into it. Simulation. They don't really talk about that one too often. If they do, it's usually with dice or spinners. But simulation is simulating a situation in some fake way. Simulation, okay, I'll show them. It's probably still wrong. No, it's still wrong. There you go. I missed putting it on fire. Normally it would be like, what's the odds of getting something if I have 8 things? I spin a spinner, you know, that has 8 sections in it, and I find the odds or whatever. You know, it's shown in some other way that's not the exact way. It could also be actually running a situation of, well, I know what this plant food parts do. Like, I know what this molecule does. If I put it in there, what's it theoretically going to do if I introduce it to it? Well, that's a simulation, usually computer-driven in some way. Okay? Do y'all feel okay with all those? I'll tell you, they really like to give you like a paragraph and say, okay, what is it? And you have to answer, especially on the sampling methods. It's really the only way to test your knowledge on it is to give you a situation and say, okay, what is this? And it's not something I can really teach. I can teach you the definitions, but at some point you have to learn how to read the situation and go there, which I think both of you will be fine with that. So I'm not really stressed about that. Okay. Would you like examples of them, or is there anything of those you want examples of you don't feel comfortable with? Chase, you good? So, no issues? Okay, that takes us out of the definition world of stats, which was a huge section. We spent several days because there was a lot that needed to be said. I did touch on things like placebo and stuff that you may want to consider looking at for experimental. I've never seen them test on it, so if you're looking over your stuff just for testing fact, I wouldn't stress about that part. I've showed you the main things they usually test on, but if ever you need to know what they are, then you may want to look back at them, or you may want to look back at them just for safety's sake. Be prepared also, instead of a survey, they may ask about a census or a poll. Be prepared for those words. The census just means everybody in the population was asked those questions on that survey. So if I was doing a census of how my classes felt about the food, every person would have to answer. If one person chose not to answer, it would no longer be a census, it would just be a normal survey. Okay. I think I covered all those. Really looks like it. I don't know, it's a mess. I was even working on it right before y'all walked in. Oh well. The next thing that we need to talk about, we called it, just kidding, is different questions that you can ask in a actual survey. We talked about there's a lot of bias. If I want to know what your favorite movie is, I literally need to say the words, what is your favorite movie? Okay? I don't need to say, wouldn't you agree that The Lion King is the best movie in the entire world? Okay? That's probably not going to find out the truth of how you feel about something. The fact of that is I led you by saying, don't you agree? I also use really strong wording, such as like the best movie in the world. Okay? Strong wording comes in effect with like patriotism a lot, things like that, or religion. So you have to be careful, like especially with patriotism, people use the, do you think it's okay for us to be killing innocent people just so we can be free? You know, you're like, you really would maybe say it's okay to kill innocent people, thank you. So you have those kind of issues. So you have leading questions, and this is question bias, I forgot to. Leading questions. Well, if I could write, this would go easier. which is something like, don't you agree? It is exactly what it says it leads. Strong wording. That's when you're going to use unnecessary adjectives like great, fantastic, sweet, or horrible, or boring, things like that. If you give any kind of description when you're trying to ask somebody's opinion, so unnecessary description, I guess would be the easiest way to put that. Quick example of so example in front of me right now is, aren't homemade gifts always better than tacky purchase gifts? Okay, so the aren't is leading, but when I say tacky purchase gifts, you're putting a negative connotation on those purchase gifts at that point. So that would be strong wording. If you ask multiple questions in one, sometimes called double questions, it would be multiple things in one question. So if I asked you about the football game, okay, didn't you think that was a well-played and short game? Well, well-played and short are two very different topics, right? It may have been a very well-played game, but it may have been the longest game in the history of mankind, especially to me. So I can't necessarily say yes or no to it. I can't just check yes box or no box. I have to be like, well, yeah, it was a great game, but super long. Or, yeah, it was really short, but that game sucked. You know, it just kind of depends. So you have to look for when people tend to ask those questions. It a lot of times applies to, you know, teaching is a good one. Sometimes a teacher's a really good teacher, but they're boring. So if I asked you, are they fun and informative? Well, they could be one and they could be the other, but they're not necessarily both at the same time. So just be looking for questions at that. I wouldn't be shocked to see a question that says, where's the bias? Or pick a question that has bias. I've seen it before. It's not as common as the sampling methods, but it is something I've seen. Okay. So that goes completely out of our realm of definitions in those sense. You're going to have different kind of graphs that you may see, like a pie chart, frequency table, stuff like that. I'll tell you the graph types. You can tell me which one you want me to focus on, because you may be comfortable with, you know, most of them. I don't think this is going to be a big issue. They may do a frequency chart. I may see that more of it. So pie chart is possible. Frequency table / graph. It is in your curriculum definitely for a stem and leaf plot. Box and whiskers, I can't remember if it's in there or not, but when we start talking about statistics, I taught pure discrete math last year, and so sometimes I get ones confused of which, because that's, you had a huge stat section in that. You should know what a bar graph, you should be able to read it. I really don't think that's gonna be on there, but, I mean, that's something you should know how to do anyways. Is there any of those you need to go over? The box and whiskers. The box and whisker. The basic layout of a box and whisker is, you remember when we talked about the 5-number summary? I don't know if you remember, but, you had the 5-number summary. And, it included your minimum number, so your lowest number, obviously. Q1, quartile 1, your median, Q3, and then your max. We didn't touch on it a lot, so you may not remember it. Okay, you can always put a list of your stats in there. I'm gonna type in a bunch of numbers, so I don't know what kind of numbers these are gonna pop up to. But that's fine, that's life. So, 40, 40, 52. Okay, that's good enough. And this is probably like something that's all over the place. If you put it in L1, remember hit stat, enter credit, remember how to do that? If you go to stat and then calc, and go to enter for one bar stat, okay, it gives you a bunch of information. The first thing is your mean, which is 39.9. Remember, it's X bar, so X bar equals mean, or the average. This weird little Z thingy, backward Z thing, whatever you want to call it, X is meaning all your numbers added together. So all my numbers added together was 479. You're probably not ever going to need it, but it is what it is. This is those numbers squared. I know that sounds like a weird stat to need, but it is in higher statistics that they needed it. You just won't need it. Now, S of X and omega X. So the capital SX and then the lowercase x. Those are your standard deviations, and it depends on which one you need for what. S of X is your sample, I think, standard deviation, and then O is population standard deviation. I probably need to check on that because I mix them up every time. So, and I'll remind you what standard deviation is in a minute. So you have to read the situation. So it kind of goes back to the example of asking people how they felt about the class, how about the lunches. If I ask everybody in the school and I have everybody's data points in there, then that's a population standard deviation. I would use that O of X for my answer for that standard deviation. If I had asked about the lunches, but I only put the data points from our classroom, that's a sample of my population. It's not my full population. So I have to put whatever S of X is. There's usually not a ton of difference, but it may be enough to matter. Okay? N is just saying, hey, that's how many data, I put 12 data points in there. So if you scroll down, that's when you start seeing your 5-number summary. So min Q1, median, Q3, max. Okay? Q1 to Q3 makes it the box. The whiskers come from min and max. So like if I was drawing this, I would put, goes up to 96. We'll say this is 100. 10, 20, 30, 40, 50, 60, 70, 80. That was really crappy. Okay, redo. Don't judge. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So we'll start that off with zeros. And you would normally do a better graph. Okay, so you have these, and I would say, okay, median's at 46, so I would put a line right there in the middle. My Q1 was 7.5. Oh, that was some really bad data. I'm very skewed. So I put it about where 7.5 is. And Q3 was 57.5. So about right here. That would create my box. Okay, this was Q1. This is median. This is Q3. Okay, I probably need to tell you what Q1 and Q3 is. Do y'all remember what Q1 and Q3 is? Okay, things like that. So median, you know, means I fall straight in the middle of the data, right? That's the exact middle point that I had. Q1 is like the middle of, it's like the median of the last half. So from here to here, from my lowest number to my median, it's the median in between those, okay? So it's 25% of my data has been hit there. This is at 50% of my data, median is. Q1 is at 25% of my data, okay? So 25% of my people scored a 7.5, okay? Which would be awful. I'm hoping that's not true. Q3 is the median of upper half, so it's the 75% mark. And I may be telling you more than you know. Once I start talking that, I just start talking that. I don't kind of stop. Your whiskers are formed by your min and max, so my max was 96. My min was 4. So I would draw whiskers onto my boxes. Okay. The box just goes from 25 to 75%, and then the back half and the front half are covered in your whiskers. You can obviously tell by looking at that box that something's wrong with that data. It's not a normal distribution, right? That's not okay. It's very much lopsided in what it's doing, which I just threw numbers in there, so I hope so. But if I was looking at test scores, if that was your test scores, I'm not even looking at the numbers, I would know something's wrong with my test because it didn't have a normal distribution at all. It had, you know, I had people that bottomed out, and then I had this crazy person who made 96. Okay. So, do you feel better about box and whiskers? Okay. Is there another one of those that you need me to go over that you don't remember? Okay. Like I said, I don't think that's going to be heavily tested, but you need to know this stuff anyway, so. Okay, so that covers graph types. Okay, we're going to talk about normal, skewed left, and skewed right. There's a lot of different ways to identify, well, not a lot, there's only a couple. Say a lot, I mean two. Ways to identify a graph and how they're shaped. So one is by how many times you see heels. So if I see one heel, that's unimodal. Think about what mode means. Mode means whatever number occurs the most, right? Well, I only had one number occur the most. It had a top and it was done, right? That's why it's called unimodal. If I have bimodal, I want to top a couple times, okay? After that, if you have multiple ones, it's just called multimodal. You very rarely will see those in generated data that people give you for a problem. Unimodal is what we'll be dealing with the most. Okay, so unimodal, bimodal, and multimodal is one way to identify something. The other way is to tell how it's moved on your graph. This very much applies especially to unimodal. It's more specific on it, so it's the different types of distribution. You have normal, which is that pretty little bell-shaped curve that you've seen quite often, and we dealt with quite a bit. You have skewed left, which actually goes higher on the right than on the left. So it's kind of weird, but we go with it. And then we skewed right, which is higher on the left. I know that you could probably look at a picture and know what it is. You could probably remember the trick, but you need to know how it lays out with mean, median, and mode for that data. If it's normal, mean, median, and mode all exist straight on the same number. Okay, so mean equals mode, which equals median. Okay. So all the numbers are the same. If I just gave you the numbers, if I said, hey, mean is 76, mode is 76, and median 76, you should say, hey, that's a normal distribution. Okay. Skewed left is a little bit different. We talked about, and I had y'all kind of guess at it. I don't know if y'all remember that, but we had mode be the highest because that's what mode means, the most, right? Something that keeps repeating. So mode is at that high point. Median's still in the middle, so it would still be about right here. And then mean would be down here. Okay, so mean is less than median, which is less than mode. So mode's your higher, mean is your lowest. And if you can just remember mode's above mean, then you should be okay to know that it's skewed left. Drawing a picture sometimes will help. Just knowing mode is the most, and it will be the high point, and that the others kind of taper down. Then you can see it visually happening at that point if you draw a picture. Skewed right, it would be opposite. So mode is here. Mode is going to be less because it's a lower number on this number line that we don't see, but we see. Then it's median, and then it's mean. A good example for like why the mean's so pulled up right there that Mr. Carpenter gave his class was that if you think about geology majors and how much money they make, okay? If I take the mean of it, the average is actually going to be pretty high because Michael Jordan, who makes a ton of money, obviously, graduated with a geology degree. Now, does he go to the geology field? No, but he still has a geology degree, so the mean for that, because of that one person, there's very few people, so it's not very high this way, but it's very high this way. It would pull it this way, okay? Where up here, this would be your people that, a bunch of people make high money, and then a very few people make low, but they make super low, okay? So I guess you could think about lawyers in that case, because you have a bunch that make a ton of money, and then you got a few pro bonos that are pulling it down because they make no money off these people. Does that make sense? That's why it pulls mean so drastically. Mean is very influenced by other things. Median's unbiased, it just goes to the middle. And then mode is just like, well, what's happening the most? That's all I care about. So know that if I give you numbers or they give you numbers, which one it would fall in. Okay? Any questions about that? Okay. Standard deviation is probably the biggest concept they're going to give you. They like standard deviation. Throughout this week, we're going to be talking, I'm going to give you released exam questions, and a lot of them are going to involve standard deviation, but in different kind of ways. Some of the questions you've seen, actually, I just didn't tell you, hey, I gave you a released exam question, but I included it on your test or something. So you've had experience with it. Let me switch pages. I showed you how to find it on your calculator. Y'all okay with that? If you have to go to, and I'll show you in class a couple times too. This is not just something I'm hoping everybody remembers. You go to stat edit, put your list in, and then it's the capital S for the sample, it's the omega, the little low, the O for the population. Okay, so if I said, hey, what's the standard deviation, you should be able to give it to me, just by data. Now that's probably not gonna happen, it's probably not gonna be one of their questions, I would expect it at least. They like to go, hey, if the standard deviation is this, and we got this information, what happens then? That's when you gotta really start applying what standard deviation means. Standard deviation only applies to a normal curve, okay? So you have this normal distribution, this pretty bell curve. It's kind of your ruler. It literally does what it says. It standardizes everything. So it takes it, it kind of divides it up into even paths, okay? In a normal curve, you start here, and that is awful. That was an awful curve, so forgive me. You have your mean in the middle, which we've already talked about. On a normal curve, you have, by just natural understanding, 3 standard deviations above the mean, and then 3 standard deviations below the mean. So, I'm going to draw 1, 2, and 3. Do y'all kind of remember seeing this?
Yeah.
They like to ask questions on it. Okay. So 1 standard deviation, 2 standard deviation, 3 standard deviation. Minus 1 standard deviation, minus 2 standard deviation, minus 3 standard deviation. Okay, even if I don't give you that curve, you should be able to still know how to draw it. Based off if I told you, hey, the mean of the test scores is 60 with a standard deviation of 5. Okay, so some pretty low test scores, but that's the way life was. You should be able to draw this curve and go, okay, well, this is 60, 65, 70, 75. So not even a lot of my students made a 75, okay, or above. And then you got backwards 65, 50, and then 45. Is that okay? So we have that. That's just the main labeling part. They will probably ask you questions that will make you do that, but then they'll make you apply it. You need to remember the breakdown of the empirical rule. They may not even say empirical rule, or they may say it and give you the numbers. I can't ever guarantee what the state of North Carolina is going to do. I just have to teach it to you. The empirical rule is a 68%, 95%, and a 99.7%. Okay? And what that means is within 1 standard deviation of the mean, front to back, is 68% of my data. So what that means in this case is that 68% of my students made between a 55 and a 65. Okay? If I wanted to know how much percentage made from a 55 to a 60, I just divide that in half, right? And go, okay, well, that's 34 here, 34 here. I would suggest if you're going to have to pick which one to remember, the full breakdown or the big number or the 68, 95, 9.7, remember the little numbers first, because that's going to be, yes.
Oh, never.
You sure?
Yeah.
Okay.
You just have 68. I was wondering you got 34.
I just divided by 2. Yeah. 2 parts. Okay. 95% exists from here to here. Okay. Back 2 standard deviation, forward 2 standard deviations. Okay. If I wanted to find how much exists just between 50 and 55, So that one little section, this 95 already includes the 68 we've already talked about, right? I need to know this part and this part. So I would have to say 95 minus the 68, which is 27, and then divide it by 2 to say, well, 13.5% is here, and 13.5% is here. Now, if you remember correctly, add up the numbers in between, 13.5 plus 34 plus 34 plus 13.5. Okay, well, that's 95, so I'm not worried, it's good. Is that okay? Okay, within 3 standard deviations above and below your mean, 99.7% of your data. You would do the same math to get 2.35%, and then 2.35%. That still did not cover 100% of your data. You still have a little bit left over. These are your overachievers that either did great or your people that just completely bombed it. Okay, your zeros of your test. There's only 0.3 left of the data, so dividing it by 2 at the very tail end would be 0.15% and 0.15%. So I suggest you know the 34, 13.5, 2.35, and the 0.15. That's the most important of those numbers. It gives you the most specific answers. Because I could easily ask a question that says, what percentage of students ended up with a score of 65 to 75. Okay, knowing the 68, 95, 99.7 is not going to help me, okay, because I just know these crazy increments. I don't know from here to here with those numbers. But with the numbers that we just got, I can go, oh, well, that's 13.5 and 2.35 combined, right? So I would just say, so what, 15.85? Is that right? My brain's tired. Yeah, that's right. So 15.85% would be my answer. You okay with that? Mm-hmm. Yeah, so even if I said 45 to 65, I just add straight across. Now don't forget if it had said like above a 65, you have to add 13.5, 2.5, but don't forget that 0.15. That's where I see a lot of mistakes happen, is they forget that little bitty one. But it makes a difference when you're calculating something or answering a question. Now, if instead of just asking percentage, if I said, hey, I had 500 students, how many students made that score? So out of 500, how many scored, and we'll use the same thing, 65 to 75. How could you find it?
You found the group, 15.85% of 500.
Yeah, so we have to find 15.85% of 500. How do we do that then?
You times 15.85% times 500.
You would have to change the percentage though. How do we change it?
Move the decimal.
Move the decimal
Left.
2 places to the left. Okay? So move it 2 places to the left to 0.1585 and then multiply it by 500. If you struggle with that, or, since I'm recording, I'll say it, if anybody struggles with that, then you could say, hey, percentage means out of 100, right? So 15.85 out of 100 equals how many students out of 500. And you can set up a proportion, and for some reason, proportions make sense to students. You just seem to like them. So you can cross multiply, you can go that times that, then divide it by 100. It's whatever. I don't care what you do. Whichever works for your brain. Okay? So do y'all feel okay with doing the standard deviation?
Mhm.
I don't think they're gonna ask you anything about Z-score. If they do, just know that it, basically the number of standard deviations. So if I told you my Z-score was 2.7, then I'm 2.7 standard deviations above the mean. That's all it means. And if I said my Z-score is, negative 1/2, then I'm negative 1/2 standard deviations below the mean. Okay, and went backwards on that. They won't give you a table or anything like that to read. They may ask a concept question. I don't think they will, but I don't technically think it's in your curriculum. But they've tested on crap before that's not in your curriculum, so what would stop them now? Here is a type of question they like to ask with standard deviation. I just gotta remember what it is. It's in your released exam, I know, so I may just wait till the end, but. Maybe not. I'll just give you that kind of question when we do the release exam. It's really not that hard. It may ask you something like, it gives you the scenario, it makes you work backwards. If I had this and this, how do I, if my percentage was this, then what was my standard deviation? And you literally are working backwards in it. But as long as you understand how to apply the concept, you should be fine. And we will be doing a couple like that in class, so I'm not really going to stress about it now. So is there any questions on standard deviation or normal distribution? Okay. Statistics is probably the shortest section that we had, so I'm just going to end it there. There's probably a couple other little things, but most it'll be said at some point. So if you can truly get this stuff down, you'll be fine on the stats on that test. I can't see you not being fine. We good? Okay. Thank y'all for coming.
Thank you.
We're gonna see if this video thing worked, and if not, then I'll have to record myself in the morning and go through it all over again. Which would not be the first time. Just be here at 4 in the morning.